So in this session, it's relatively fast, just before coffee. We're doing a bit of a research snapshots update, and it's really around trying to support the added value opportunities that are out there in the industry and trying to make sure we develop on those as much as we can. So with that, I'm going to invite Sheila Alves, a researcher in Oak Park, to the stage to talk a little bit about intercropping. Sheila?
Thanks, Michael. Good morning. So why are we looking at producing pea in Ireland? Three main reasons. There's a growing market for plant protein ingredients. The pea flour and the protein isolate have a potential added value, and Irish reports the highest yields in pea compared to the other European countries. However, the production area is very small, and that's because the crop is considered a high risk. And that's due to yield losses that happen when we have severe lodging before harvesting. We need to mitigate the risk of lodging, and we are trying to use intercropping of legumes with peas to reduce the risk of lodging. I'm going to present results of this season, the past season, both in Oak Park and in participating farms. In Oak Park, we are looking at selecting best varieties, best ratios of pea bean and total seed rate to have mainly a pea crop with a little bit of beans with low risk of lodging. I'm just going to present a snapshot. I chose a variety of faba beans that has a standard maturity, Lynx. They were intercropped with pea carioca at a total seed rate of 80 seeds per square meter, and a ratio of pea bean 70:10, and the rest are controls. So, and here is the results on the, on this axis, you have the yield. On this axis, you have the height at harvest. This green column is the yield, and the white dot with the red highlight is the height at harvest. This particular column in green is the yield of carioca, sol pea plot, grown at a seed rate of 80 seeds per square meter, which is the usual commercial seed rate. It was harvested on the 24th of September. At this stage, faba bean was not ready to harvest. So the intercrop was only harvested 3 weeks later. And the yield was 5.2 tons per hectare, and as you can see, you have here the pea to bean ratio. And most important is to compare the height of the sole crop with the height of the intercrop harvested 3 weeks later. Both of the heights are above the ideal harvest height, which we consider is 20 centimeters plus. Obviously, we can harvest when the crop is lower, but the chances is we will have a crop with much more debris and potentially more moisture. These are just the controls harvested at the same harvest date and the same seed rate in the intercropping. And as you can see once more, the height of the intercrop, it's much closer to the bean crop on its own than it is with the pea crop on its own. The conclusions from the plot trials is that intercropping increases the harvest window by at least 3 weeks while maintaining the yield. Lodging is decreased by intercropping, but several parameters need to be taken into account, such as the seed rate and the variety of beans. We are looking at beans that have strong stems, but that grow fast. So we can harvest both crops at the same time. Looking at the on-farm results, we had 6 participating farms around the country. We asked the farmers to have 0.5 hectares of pea only. The seed rate was 80 seeds per square meter, variety Carrington, and then an area of 0.5 hectares intercropped of pea bean at a seed rate of 100 seeds per square meter and a ratio of 70 peas to 30 beans. We chose a variety of bean that is fast growing. So we sow in April based on the optimal dates for pea, but we harvest both crops together because we use the fast growing bean. Results. So for the height at harvest, you can see in the graph, in orange we have the areas of sow pea and, in green we have the areas of sow pea and in orange the intercropped areas. And as you can see, all the intercropped areas have higher height than the sow pea areas. Because the season was very good for peas, they are also, both areas are much higher than the ideal harvest height. So there was low risk of lodging this season. In terms of yields, we didn't find differences between intercropped area and sow pea area. And we think this is related with the good season for pea that make the crop outgrow the bean, so it outcompetes the bean. So what are the lessons we learned from previous seasons in terms of using intercropping? In a favorable season, such as 2024, intercropping decreased pea lodging. There's a potential to increase productivity, but there's several factors that need to be taken into account. In an unfavorable season, when the pea crop lodges severely, intercropping will mitigate the risk of pea, increase the harvest window, mitigate the risk of pea crop lodging, increase the harvest window, and ensure lower yield losses compared to the pea on its own. I just want to finish by thanking all the farmers that participate in this study and the people in Oak Park that helped doing these studies. Thank you.
It's great to see you. Yeah, you might join me here, Sheila. Thanks very much, Sheila. So, as Sheila's work showed, it's a lot around trying to increase the level of peas grown in the country, but we need somewhere to use them. So I'm going to invite Eimear Gallagher, who's a food researcher in Oak Park, just to talk about how they can be used, how peas and beans can be used within the food sector. Eimear.
Morning, everyone. As Michael said, my name's Eimear Gallagher. I'm actually based in Ashtown, not in Moore Park, so I'm in the Food Research Centre in Ashtown in Dublin. Not to get political about it. What I'm here to talk today about is food applications, or I'm kind of looking at the end of the line. So I'm taking a lot of the work that Sheila is doing with her crop science research and then applying some of her crops and some of her intercrops to end products, and particularly bakery products. So in Teagasc, Ashtown, we're very lucky that we have a significant amount of extensive food research facilities, and in particular we have a number of cereal and bakery related facilities. These would include milling facilities where we're able to mill different types of grain, hard grains and soft grains, and then use these grains to produce different types of flour with different particle sizes for use in different types of bakery products. We have a test bakery as well where we can produce a range of different bakery products. Then we have a cereal chemistry lab where we can assess different properties of the flours and the products that we make. We have access to what we have in Ashtown is the National Prepared Consumer Food Centre. So that gives us access to a range of different types of processing facilities. So we have thermal and non-thermal facilities where we can treat grains and treat flours, maybe to alter their structural and their nutritional properties. We have a dough rheology and a spectral lab where we're able to study the flow properties of doughs, their elasticity properties, and also we're able to look at the spectral footprint of the doughs and grains and products as well. We have a sensory science suite in Ashtown, which consists of 20 computerized sensory booths, and we have an externally trained panel who come in twice a week or 3 times a week to taste different types of foods, and they're specifically trained for different types of food. And of course, before we do any sensory work, we always make sure that they're micro-safe and chemical safe. And then in Moore Park, we have access to the National Imaging Centre, which consists of a range of different microscopes. So we're able to look at the microstructure, or very in-depth detail into grains, flours, and bakery products. So in keeping with current research, I suppose, and current consumer trends, we have started to do a lot of work in plant protein. In particular, I have a particular interest in Irish-grown crops, so alternative uses for Irish-grown crops, in particular for bakery product use. So Teagasc has funded a project, and I have a PhD student working on this, called High Pea Breads. And in particular, we're looking at Irish-grown peas and applications, particularly in bakery products for these peas. So we're working in conjunction with Sheila, who's very helpful to all of our research. And at the moment, we're looking at different milling technologies for Irish-grown peas. So what we have done so far is we have taken the peas that were grown in Oak Park, and we've put them through 3 different milling regimes. So we have roller milled them, we've put them through a cutting or a knife mill, and also a hammer mill. And we have looked at the resulting flours from each of these types of mills. So the roller mill works by compressing the dough and then sifting it into different particle sizes. The cutting mill consists of shearing. It's more like knives working really quickly, so shearing. And then the resulting flour is sifted through a sieve of 0.7 microns in size. And then the hammer mill is something that would be used a lot in the milling industry, where the peas are actually broken, and then they are sifted through 0.8 micron sieve. So what we're doing then is we're taking each of these flours and we're looking at the resulting properties, so things like the protein, the dietary fiber, the starch, how well they work when they're blended maybe with wheat, how they work in a dough and how they work in a bread, and then what the end product is like as well. So we characterize the flour, then we blend it in a ratio of 15 to 85% pea with wheat. So we started at a low level initially just to see how it worked to replace dough by 15%. Then we characterized the blend of flour. Then we used kind of mixing technologies to look at the water absorption to make optimal flours with these blends. And we characterized the dough using rheological methods. And then we also profiled the bread over a 7-day staling period. And this is just some pictures of the breads that we produced. What we have found is that, in particular, as you would have expected, the protein content of the bread was significantly increased. Also, the dietary fiber content of the bread was increased in comparison to a normal wheat bread. And then what we found using the hammer mill, which is cutting the peas by force and then sifting it through 0.8 micron sieve in the mill, gave the highest yield. So there was very little waste or very little loss using this kind of milling. What we also found with this type of bread, which is up here, that it was quite comparable to the wheat when the wheat was replaced by 15%, particularly in terms of bread staling and bread texture, that the bread staled at a very similar rate, and also that the microstructure was quite improved. As you can see here, we just take a section of the breadcrumb and put it under a microscope, and we stain for different properties of the bread, so we can look at the protein, we can look at the starch, and we can look at the cellulose materials. So in particular, we found that the protein level was significantly increased without significantly affecting the staling profile or the consumer acceptability for sensory trials. So what we're doing now in this particular project is we're looking to increase the level of substitution in a wheat bread more than 15%, because 15% is quite low. So we're looking to increase it up to 35 to 40%. And we're doing this by treating the grains before we actually mill them. So we're germinating them, we're putting them through ultrasonic and microwave treatments, and we're finding that these are actually changing slightly the structural properties of the peas. It's decreasing the green colour, which is also a good result. And what we're doing now is we're looking at in vitro digestive studies on how the actual functional properties of the peas are being absorbed in the gut. So this is research that's going on using Irish peas. This is a project that was recently funded by the Department of Agriculture, so I'm coordinating this with UCC and UCD, and it's called G3IE. So what this project is focusing on is Irish-grown fava beans. So not peas this time, it's fava beans. And you might think that gluten-free or developing gluten-free foods is quite niche and maybe not worth the effort or not worth the money, but when you think about it, and we're working with the Celiac Society and we're working with their consumer panel of 4,500 people on this, the amount of celiacs in Ireland is the greatest in the world. There's 450,000 people in Ireland that are either celiac or gluten intolerant. So there's a very kind of big market for gluten-free foods. And also it has been found that 1 in 5 people shop for gluten-free foods very regularly. So there's an increasing demand for gluten-free food. The thing with gluten-free food, and we also work with dietitians and nutritionists in the Celiac Society, is gluten-free foods aren't usually fortified. You know, the way you get breakfast cereal that can be fortified with folic acid or with vitamin D or with iron. That's not the case with gluten-free food. So this project is focusing now on using Irish-grown fava bean, which are very high in micronutrients, fibre and protein. And we will be working again with Oak Park to select Irish fava bean cultivars that have low anti-nutrients. So they will have low V-cine and conv-cine and low phytates. And low tannins, and we will be processing these fava beans and doing similar work to what we did with the peas, but this time for gluten-free. So we'll be looking at gluten-free breads, also gluten-free breakfast cereal and flaked products using the facilities that we have in Ashtown. Something interesting that we'll be doing here as well is we'll be constantly focusing or monitoring the healthy or the functional properties of the resulting products. So our colleagues in Moore Park, who are involved in the project as well, will be building a celiac gut. So they'll be simulating a celiac gut and seeing how the nutrients in the fava beans are absorbed compared to a non-celiac gut. And we'll be doing an LCA as well, a life cycle assessment based on the social, the sustainability and the economic aspect of the project. And then the final project that we're working on in the Irish crops area is the Valpro Path, which Sheila has described very well. So we will be taking what Sheila has been working on for her intercropping trials, and we will be blending fava beans with peas. So we're going to be using the work that we've done previously on the pea, so continuing with hammer milling of the peas. And then we've also just started working on fava beans. So we have been able to purchase some facilities for processing fava beans. So we are looking at dehulling, which gets rid of the outer layer of the fava beans, and this is where the tannins are contained. So this contains the bitter flavour for fava beans and also the anti-nutrients. And also we will take these then and we're aspirating them, so we're blowing off the shells. So we're left then with the very clean fava beans, and then we're milling these to make pure fava bean, Irish fava bean flour. Then we're blending the pea flour and the fava bean flour in a blend of 70% and 30%, and we're also looking at 90-10, but we're really focusing, as Sheila said, on 70%, 30% fava bean. And we're using this to replace 30% wheat flour. And we're looking at, again, the rheological properties, the mixing properties, the microstructure, the sensory, and of course the healthy or the nutritional properties for a range of products. So we're supposed to be, for the project, we're looking at a range of 4 or more products. So to date we've looked at some crackers and some cake, which have worked very well. What we're doing now for the future, once we get the new harvest of intercrop products, we'll be looking to increase this 30% to 40 or 50%. So we'll be replacing wheat flour by 50% with intercropped Irish blends of pea and fava bean. So that's just some of the work that we're doing in Teagasc and Ashtown at the moment from the food side. It might be a little bit different to what you're going to hear for the rest of the day, but it's interesting, I suppose, to hear that there are end applications or food applications to all of the work that is being done in Oak Park. I'm just going to go back because I would like to thank, so I'm just here presenting on behalf of some of my group who are doing all of this work. So I'd like to thank those, and thank you very much for your attention.
It's great, Eimear. Thanks very much. It's great to see that integration of work from field all the way through. You might join us up here, Eimear. So we're running out of time rapidly. I'm going to invite Diana to the stage. Diana's working on oats and around the potential hazard of mycotoxins in oats. So Diana, the floor is yours.
Thank you, Michael. So my talk will be slightly different from the previous ones. I'm going to talk today about mycotoxins present in food-grade oats, about the fungal species producing them, why they're important, and what we can do to control them. And I'm going to start with what is the current challenge in Irish oats in terms of mycotoxins. Well, the problem is the European Commission is moving towards more strict regulations regarding the T2 and H2 mycotoxins found in cereals, and particularly in oats. Maybe some of you are aware the previous limits for these two mycotoxins, the sum of the two mycotoxins in oats was of 1,000 microgram per kilogram. However, starting with July 2024, these limits dropped to 200 microgram per kilogram for unprocessed oats. And for processed oats, for direct consumption, the limit is around 100 microgram per kilogram. In addition to the new limits that are more strict, the EU is also enforcing more testing of the oats. And in this case, if a sample of oats tests over the limit, the new limit, this could be rejected at the mill, or it could be diverted for animal feed, which could cause financial losses. Because of this, Ireland's reputation for high-quality oats depends on keeping the mycotoxin levels low. And what can we do to do this? The solution of the problem is to tackle the problem at its source, which is to manage the risk of Fusarium infection. And to do this, Mycotoxide Project is proposing a field-to-fork strategy to assess and mitigate the exposure risk of mycotoxins in Ireland. And in this project, we started by developing a very strict sampling framework to target the various factors that are contributing to the accumulation of mycotoxins in oat crops. Based on this sampling framework, we collected oat samples across Ireland for multiple years. And using these samples, we assessed the level of toxigenic Fusarium species present in the sample. We also looked at the level of mycotoxins in the samples, but also the levels of mycotoxins present in some field trials that we have in Teagasc. And based on the results from these assessments, we can see what the problem is, what's causing it, where we are, and what we can do. As I was saying, the first step in the project was to develop a sampling strategy for oats. And we looked at various types of crops. We looked for organic crops, but also conventional crops. And in terms of conventional crops, we looked additionally at the time of sowing. So we sampled spring crops and winter crops. And in addition to sowing time, for both spring and winter crops, you also looked at the rotation. So we sampled oats from a cereal or a non-cereal rotation. And additionally, we also looked for the establishment method, and we sampled oats that were established using a plowing system or mean tillage. Once we collected all these samples across Ireland, we moved to assessing the level of mycotoxins that are present in these samples. And the problem is that mycotoxin-producing Fusarium species were present in all the crops. However, the prevalence depended on the crops. As you can see in this graph, at the bottom, you have different numbers for each of the sample. Each line, each bar is one of the samples that we collected across Ireland. And the numbers are meaning that for each of the locations, we were able to isolate a different number of Fusarium species. Moreover, and more importantly, Fusarium lancetia, the one that you see here in light purple, is the main producer of T2 and H2 mycotoxins in oats. And as you can see here, it's present in the most samples, and particularly in the oat crops from cereal rotation. However, there are some good news as well. And the good news for that particular year, 2022, the good news was in the levels of the key mycotoxins that we tested. And these limits were still low. As you can see, there was only one sample that had a high level of the sum of T2 and HT2 mycotoxins, and the majority of the samples were below the limits, even below the new limits of mycotoxins set in place, regardless of the rotation or the sowing date. So this means that although the hazard is there and we have to mitigate it, it doesn't necessarily mean that the mycotoxins are always present, and this depends on various factors. And I have to mention here that 2022 was a very low disease pressure year. So this means that because of the high temperatures and dry weather, probably the levels were low, but that doesn't mean that this cannot change for the next years. And to conclude, the hazard of fusarium is contact and mitigation is essential, and we have some recommendations for it. The recommendations that we have here are the ideal recommendations to target specifically fusarium. In terms of fungicide management, it's important to rotate azoles and the correct time to time correctly the spraying. However, the current fungicide programs are targeting rather rust and mildew than fusarium. In terms of field practices, it's important to focus on a good crop rotation to reduce the fusarium inoculum. And from our previous results, fusarium is accumulating in the cereals. So in a cereal rotation, we would have more fusarium than in a non-cereal rotation. In terms of harvest and storage, it's important to dry quickly the crops to inhibit fungal growth. And of course, be aware of testing and the threshold limits. So that's everything for me. Thank you.
Thank you very much. Thanks, Diana. You might join us back across over here. So we have about maybe 5 or 10 minutes for a few questions. We're eating into our coffee time, but we will just take a few questions here. So there's a few here from Slido, so if you want to ask a few more in Slido, please work away. Or if not, we have put up your hand and we'll take a few from the floor as well if somebody wants to ask a question on that. Sheila, I might start with you. Sheila, the question here is in terms of is it total yield or the P yield, or which is better? Is it total yield or is it the P yield under intercropping? I think that's the question, is it? Is it total yield or the P yield?
Mention about intercropping.
Okay, so it's a combination of both you were showing, but I think it's, is it the total yield or just the P yield?
So we showed the total yield in the slides. So it's the sum of the P yield and the bean yield. And usually the P crop would outcompete the beans. So if there's a reduction in yield, it will be in the bean yield.
It'll be in the bean yield?
Yes, exactly.
Okay, in the bean yield, okay. So the peas are relatively competitive?
Yes.
Okay,
yes.
In comparison to...
But this only happens at high seed rates in good seasons. Usually they don't antagonize each other.
Okay, okay. There's a question here around milling wheat. There's some offers of milling wheat out there at the moment, and the question is around, are we doing some research around milling wheat, both on the agronomic and processing side of the house? Eimear, are we doing a little bit in the processing side of the house? We'll continue to do that?
There is work going on at the moment. There is a national project called Protein I, which has been funded by the Department of Agriculture and Northern Ireland. And some of the results from the milling trials, the last 3 harvests of wheat, will actually be presented at the Crops Open Day in June. And the results from the 2024 harvest are being analysed at the moment. So there is work going on, also work that has been funded by Teagasc. There's some research going on in that area too.
Okay, so similar to the peas and beans, there's kind of both sides of it, the agronomic and the whole way through the system. Yeah. Okay. So there's a question here around, Diana, maybe one for you there, around is there any biological control systems around the control of fusarium? I presume that's in field.
We have something in the project. One of our partners in the project is currently doing some work on biocontrol in glasshouse, specifically targeting Fusarium lancetia. From what I know, the results seem positive in glasshouse, but for the moment it was just tested in these conditions. So it will need more testing and to move to field to see it's actually the results that are in the glasshouse could be translated into field environment.
Okay, so there could be many a slip between glasshouse work and field work. That's probably the way of a lot of those kind of products. Okay, Sheila, maybe back to you. In terms of the variety choice, in terms of intercropping, is there a limitation there in terms of the varieties that we can pick?
There's a limitation on variety picking for faba beans, and there's no recommended list for peas. This follows the interest or the area of production. So there's a lot of varieties in Europe. Selecting varieties to do intercropping follows certain rules, as I said, like the strength of the stem or the maturity. But in the end, the lack of variety, it's not for the intercropping, it's for the two crops involved already.
Okay, so lots of synergies to be taken into consideration.
Yes, that's true too.
Okay. Maybe one for maybe both Sheila and Eimear a little bit around the crop cleaning and separation technology. That's advanced a little bit. Are we looking at a little bit of that in terms of if you're growing, peas and beans, or maybe oats and peas or oats and beans is put up there, in terms of separating those out into different components?
The biggest difference between size or shapes, the easiest is to separate. There are, even for peas and beans, can have similar sizes and similar shapes, at least the fast-growing ones. There are mechanical options to separate them. In our work, we don't want to separate the crops. We want to use a crop that is 90% pea with a small quantity of beans. And we don't want to separate it because we don't want that added cost.
Okay. And Eimear, just in terms of, can you process both of those together if there's only a small quantity of one?
It's something that we could look at because we have so many different types of mills, and the mills we have are for hard grains and soft grains. For oats and beans could be interesting. For peas and beans, because they mill quite easily together. Oats and beans would need a bit of work, I think, for processing. Like, we wouldn't separate them, as Sheila was saying. If we were to process them as an intercropped option, it would be interesting though, because both the oats and the beans would bring different functional properties to the end product. So it's just the processing would need to be looked at quite in depth, I think.
Okay. Right, we're getting close to the end of some questions then. I just wanted to pose one to you here, and it's around, I suppose, the future and climate change. Just in terms of if climate is going to change that a little bit more, is there a possibility we're going to get more mycotoxins? Is that a bigger risk?
It's a good question, and climate change will definitely impact the level of fusarium and also of the mycotoxins in cereals, because the current models, I think, are showing that the climate change will move towards more humidity and heat, so that are the ideal conditions for the development of fusarium and production of mycotoxins. So definitely there will be more fusarium out there in the field, but I think also it will, the high level of humidity will also affect the storage of the crops, which will also impact the development of the mycotoxins in the drying process.
And from a practical point of view, in terms of controlling mycotoxins in the field, that's a fungicide at the head timing, or what's the? Yeah. So the ideal springtime would be when the panicle is emerging. But as I was saying in my presentation, the current fungicide spraying programs are targeting rust and mildew, so it's not exactly the ideal time for fusarium. This is not something that we are targeting in particular at the moment, but with the changing in regulations and the future problems that may arise, it's something that we need to pay attention to. And as I was saying, also it's very important to test. So at the moment, in what we are doing, the work we are doing in Chagas, we are focusing on what we have at the moment, what we are dealing with, to know what is the starting point and what we can do from there. Okay. There is a question up there. It's probably it's a tricky enough kind of question, I suppose, in terms of replacing imported fibre sources. But maybe to Eimear, in terms of some of the projects, in terms of trying to fractionate some of the products we have there, that might be a method towards getting more fibre back into the system.
Yeah, absolutely. When depending on the milling regime or process that you do, you can fractionate. You can fractionate for higher protein fractions or higher fibre fractions. Not sure if that's what you mean. Like you can certainly fractionate the grain and sift off the outer levels, which would have the higher protein fraction. This can be used as a kind of functional food ingredient that would have higher levels of soluble dietary fibre.
Okay. We're going to leave just one last question. I'm going to ask it to Sheila before we go for coffee. Sheila, there's a question there around lodging resistance and the improvements in terms of intercropping. And the question is around, what was the lodging pressure like in the controls? And I suppose this year, 2024, I should say, or last year, 2024, was a good year in terms of peas standing in comparison to normal. You might give us a bit of an insight into that.
So a pea crop is always falls a bit. And when I say a bit, it can go from 1 meter and 20 to 60 centimeters at harvest. So very different from beans. What we notice this year, the intercrop was at harvest was always higher than the sow pea. Previous seasons where we had severe lodging, we noticed the same, but with much bigger differential. So the peas would be, we had some plots for specific peas where we couldn't harvest at all, and the intercrop with that peas were still below that, what we call the ideal harvest in the limit height of 20 centimeters. The intercrop was still above, and we harvest with low contaminants and low moisture.
Okay, perfect. Listen, you might show your appreciation to the speakers.